Alright, continuing with the Chapter 3 test, looking at number 24, it reads that you are helping to set up chairs for a class performance. There are 6 rows of chairs. Each row has 16 chairs, so 16 chairs per row and 6 rows. Find the total number of chairs. Well, that's just 16 times 6, so 96 chairs. Number 25. Use the distributive property to simplify 5 times 52. Okay, well 5 times 52 isn't something we normally would do in our heads, but if we can make it look more like 5 times 50 plus 2, then we can do 5 times 50 is 250 plus 5 times 2, which is 10, and so in our heads we might be able to get 260. Alright, number 26. We have explain how to use prime factorizations to find the LCM of two numbers. Include an example. So we actually do not use prime factorization to find the LCM. We use the Agna-Patel method, and so we can just show an example of that instead. So let's say we wanted to find the LCM of 8 and 10. An example of that would be we find the lowest prime number, which is 2. So 2, oops, I'll put that up here. So 2 goes into 8, and 2 goes into 10. 2 goes into 4, but not 5. 2 goes into 2, but not 5. And 3 goes into neither, so we go right to 5, and that gets us to 1. So we multiply all these together and realize that the least common multiple is going to be 10, 20, 40. LCM equals 40. Alright, for number 27, find the LCM for each set of numbers, so 4 and 8. So we can use 2. We can use 2 again, and we can use 2 again. And so the least common multiple is going to be 8. Let's try number 28. LCM for 6 and 11. So we have 2, and that makes that a 3. We have not 2, so 3 again, or not 3 again, 3 for the first time. Now we just go right to 11. So it's 33 times 2, so 66. Let's try number 29. LCM of 3 numbers this time. So we have 10, 12, and 15. Alright, we'll start off with 2 as usual. 5, 6, 15. We'll do 2 again. So we get 5, 3, and 15. Can't use 2 anymore, so we'll do 3. And we can't use 3 anymore, so we'll go to 5. And that's it. So it'll be 15 times 2 is 30 times 2 is 60. So the LCM equals 60 in this case. Alright, starting on number 30, we are simplifying each expression to combine like terms, or simplifying each expression by combining like terms. So this first one starts off like this. I think this is the thing that most students are being confused by. When each of the terms has a letter in it, like in this case, they can be combined using addition. So 3 plus 4 plus 5 is 12. So 12m is the answer for number 30. Moving on to 31, we have 3d plus 9 plus 5d minus 4. So the like terms here are 3d and 5d. Like terms but different, So the 9 and the minus 4 go together. So we're going to end up with 3d plus 5d is 8d, and then 9 minus 4 is 5, so plus 5. And we have to stop here because 5 does not have a d in it, so we're done with that one. Number 32, we have 4x plus 10x minus 3. So the 4 and the 10 both have an x with them, so they can combine to become 14x. The minus 3 does not, and so we can't go any farther than that. Alright, I think we have room for one more here. So for 33, we have 21r minus 18r plus 14. So these first two terms have an r in them, so we can actually combine them with addition or subtraction in this case. So we have 21 minus 18 is 3, and they both have an r, plus 14. So again, we have to stop here because 14 does not have an r to go with it. Alright, moving on to 34. If r is the area of a rectangle and t is the area of a triangle, write an expression for the area of the rectangles and the triangles. So we have a picture here. Let's see if I can... We have some... That's a square. So we have some rectangles, and we have... So two of those. They're the same size, but the ones I make might not be. And we have a rectangle, a couple triangles. So it looks like there's 3 triangles and 2, nope, 4 triangles and 2 rectangles. And so if R is the area of the rectangle and T is the area of the triangles, write an expression for the area of the rectangles and the triangles. Well, since we have 2 rectangles, we can say 2R. And since we have 4 triangles, we can say 4t. Another way you could do it is you could say r plus t plus t plus t plus t. Keep in mind my t's have a little curl on them so as not to confuse them with a plus sign. So 4 triangles, 2 rectangles. There you go. Either one of these is acceptable. Number 35. Jamal bought 7 tickets to a baseball game. Each ticket cost $15, so 7 at 15 bucks. To find the cost, he added the product 7 times 10 to the product 7 times 5. So he did this. And figured out that it costs $105. Which property did Jamal use? So what he did is he took this, and which looks like this, and he changed it to look like this. He then used the distributive property to multiply and get 70 plus 35, which is 105. Alright, and that should do it for the Chapter 3 test. Hopefully you can watch these and get an insight into any things that you had questions about. Come to school Monday with questions. I'll be here early, but we can also talk about it in class. Thank you very much.